All right, guys, so we made it to the last lesson of chapter 7. This is called factoring polynomials completely, meaning we want to have them as far simplified as possible. So we're going to break this lesson up into a few little segments. In this assignment, we're only going to complete this first page, okay, which is called factoring by grouping. So I want you to glance through this first page and notice something different about these 6 that we're going to do compared to any of the other ones that we've done before. Okay, so what do you notice? Yeah, there's 4 terms here. So that's why this is going to be called factoring by grouping. Now this first part actually clearly explains what it is that we're going to do. It tells us all of our steps. So it's going to say, first, group the terms into pairs, then factor out the GCF out of each pair of terms, then look for and factor out the common binomial factor. And then we have our answer. Okay, now that sounds like some obscure steps, so we're going to, like always, we're just going to work through some together. Okay, example 1, factor by grouping. So I look at my problem and it's in standard form. It's going to be really helpful to have it that way. So you want to make sure it's always meaning largest exponent goes down in decreasing order and we end with our constant. Okay, that's standard form. Alrighty, so I'm going to group them. I'm going to put parentheses around this and around those two. And if we think about like numbers, if I'm adding 1 plus 2 plus 3 plus 4, if I group these two and group these two, I'm going to get the same answer. I get 10 as if I had just done 1 plus 2 plus 3 plus 4. I'd get 10 that way as well. So that's where we have like commutative property, associative property, where we associate things together. So that's where that applies. So anyways, I've grouped the first two and the last two. Now I look at my first two, and I see, is there a GCF within these two values? So kind of cross out, you can almost think of it as like covering up that and just focusing on the first part, okay? So I can factor out an x squared. All right, so let's factor out x squared. What I'm going to have left in this first term is x plus 3, okay? All right, so now let's move on to the second parenthesis set. And when I look at these here, 2x plus 6, I look for a GCF within those. So here I can factor a 2 out. When I factor 2 out, I'm going to have x plus 3 that remains. And again, you can always go through and just redistribute. 2 times x is 2x, 2 times 3 is 6, x squared times x is x cubed, x squared times 3 is 3x squared. So I haven't changed the problem, I've just rewritten it. I kind of think of it as like manipulating it to get it to do what you want. Okay, now, what do you notice? We see here that this and this are exactly the same. And that's exactly where we want to be. So technically, that's where this step 3 comes in at. Then factor out that common binomial. So basically, they both have this in common, so I'm going to pull that out, okay? So since they both have that in common, now I'm going to write the x plus 3 outside. Now since I pulled this out, and I pulled this out, what's left is, when I factor x plus 3 out of here, I have x squared left. When I factor x plus 3 out of here, I have plus 2 left. So some people just say, oh, you write the common thing first, and then you write whatever was left second. And that technically works, okay? All right, that's called factoring by grouping. Let's move on to letter B. Okay. All right, letter B is a little unique. It has 2 different variables. So in terms of standard form, I look and I say, we're not talking about standard form for 2 variables. But I see, if I were to group them this way, is there anything I can factor out of x squared and y? And there's not. So if you get to a point where you can't factor anything out of 2 of them, you're allowed to rearrange the order. So I'm going to write this as x squared plus x plus y plus xy. Okay? All right, or I could even rearrange it and say x squared plus x plus xy plus y. The point is, you can rearrange these variables in any order you'd like, commutative property. So now let's go ahead and do our work. I'm going to group my first two, group my last two. I'm going to factor an x out of the first term, so I'm left with x plus 1. If I redistribute that, I get x squared plus x. Then on this second polynomial, this binomial here, I can factor a y out. I'm going to get x plus 1. Notice again, we did a good job because those are the same. So when I write my answer, it's going to be x plus 1 and then x plus y. So I write what was in common to both of them, and then I write whatever was remaining next. All right, we're going to try just 4 more, and then you can try some on your own, okay? All right, so if you feel ready to go ahead and move on by yourself here, I don't want you doing homework yet, but you can try these 4, pause it, and check back, or just keep watching and we'll do them together. Okay, now I'm going to look at number 1. It's not in standard form, so I'm going to recommend we go ahead and do that first. 8s cubed minus 64s squared plus s minus 8. Okay? Again, we have that freedom to write it in any order, but I like to start in standard form and go from there. So I'm going to group my first two and my last two terms. In terms of the first binomial, so 8s cubed minus 64s, I can factor out a GCF of 8s squared. 8s squared goes into both, so 8s squared times s gives me 8s cubed. 8s squared times 8 gives me 864s squared. So again, if I redistribute that in, I get what it said before, okay? Now let's look at the next one. The next binomial, I notice already this is s minus 8 and that's s minus 8, so I really don't have to do anything. Plus, there's nothing I can factor out of s minus 8. So if I want, I can rewrite it just so I understand it clearly as plus 1 times s minus 8. So when I rewrite my final answer, s minus 8 is one binomial, and then 8s squared plus 1 is the second. So reiterating, whenever I pull the second one, it comes from here and here. Okay? All right, let's try number 2. All right, so I'm going to group the first two. And now I'm going to, we know that minus is plus and negative, so I'm going to write that as plus and negative. So we have, just so it's like, we always have this plus sign in the middle here. I'm just going to keep that as a plus sign right in the middle. So I've rewritten this as plus, and then, sorry, that's a negative 30. Same thing as minus 30a, I wrote negative 30a. Alrighty, so in my first binomial, I can factor out 2a squared. 2a squared times 6a gives me 12a cubed, plus 2a squared times 1 gives me 2a squared. All right, my plus sign comes down. Now on the second one, I want to try to get it so when I factor GCF out, I get 6a plus 1. So I notice that 5 goes into both of these. Now if I factor out only a 5, let's see what happens. I'm going to have negative 6a minus 1. I'm so close, but my signs aren't matching. So what that is, easy fix. All I need to do is instead of factoring out a 5, let's factor out a negative 5. So negative 5 times 6a gives me negative 30a. Negative 5 times 1 gives me negative 5. And by doing that, just easily changing that, those two are the same. So I can rewrite this as 6a plus 1, and then 2a squared minus 5. Okay? All right, moving on, number 3. Here's another one of those interesting multivariable ones. So I'm going to rearrange the order a bit. It might work, it might not. But the reason I'm rearranging it is because just off the bat, d squared and 2c, there's nothing that comes out of this first. There's no GCF for d squared and 2c, so I can't do it the way it is. So let's try a different order. How about d squared plus cd plus 2c plus 2d? Okay, now if I try something and it doesn't work, there's 4 terms here. I can rearrange them again. But don't worry, you're not going to have endless options. Usually you come across it pretty quickly, if not right away. All right, the first term, I can factor a d out. They both have a d in common. So I'm left with d plus c, because d times d is d squared d times c is cd. In my second term, I can factor a 2 out, and I'm left with c plus d. Now you might say, whoa, wait a minute, they are not the same, but isn't 3 plus 4 the same as 4 plus 3? Yeah, they're the same thing. They're just, they're just written in a different order. So that's okay. That would just mean technically like those two terms get flopped. So I'm able to pull out a d plus c, or you could write that as c plus d, it doesn't matter. My second parenthesis is d plus 2. Okay? Now, if you're not sure if you're on the right track, you can always go back and FOIL. So let's just check. First gives me d squared. Let's write that in a different color so it stands out. First is going to give me d squared. Outer is going to give me 2d. Inner is going to give me cd. And last is going to give me 2c. Now, when I look at the original problem, is it in the same order? There's a d squared, 2d's at the end, cd's right here, and 2c's right here. That's fine. That's not going to be important right now, because again, you can add things in different orders. That's perfectly fine. Commutative property. All right, so we did that one. With that said, sometimes there's other ways, like people might write c plus d, 2 plus d. You can have them in different arrangements as long as one of your parentheses has a c plus d or d plus c, and the other one has 2 plus d or d plus 2. Okay, so as far as which goes first, second, that's kind of dependent on how you set it up initially. But so in that sense, there's multiple answers. Last one, I hope it's not too wordy. Anyways, look, it's already in standard form. That's great. So I can factor out, nothing goes into 5 and 6, but I can pull a t squared out. I'm going to be left with 5t plus 6. Now, right away, 5t plus 6, 5t plus 6, so we're good to go. So this is one where I'm really only going to factor out a 1. It's not critical that I write that, but it helps when I go to do this next step. 5t plus 6, and then t squared. I have that 1 there, so that just reminds me that it's plus 1. Okay? All right, that's it. Good work, guys. See me with questions of any kind. If you want to even just review factoring out a GCF, like just this part here, I'm happy to do that with you, okay? All right, thanks. Great work. Bye-bye.